Here in this video, we're going to look at solving linear systems, and that's systems of equations and inequalities again. And this time, our expressions are not going to be written in slope-intercept form. They're going to be written as maybe a combination of slope-intercept form and standard form, or neither one, and we're kind of work our way around it to still get our set of answers. So looking here at this first problem, I want to find the solution to this system. And I'm looking in, well, first of all, we're given the equation y is equal to negative x plus 2, and that one is in slope-intercept form, so I'm good to go. I can go ahead and graph that one, but I'm going to go ahead before I get into the graphing stage, and I'm going to rewrite this other equation. I need to get it to be written as y equals, and so what I would do first is I need to isolate the y, so I'm going to move the 3x here to the other side, so I got to subtract the 3x from both sides. It gives me negative y is equal to negative 3x plus 6. And then I need to divide everything by a negative 1, so that way it's in slope-intercept form for us to graph it. We have y is equal to positive 3x minus 6. So I have my two equations, and we are ready to graph them. So we'll start with that one we just solved for. We have a y-intercept of negative 6. We have a slope of 3. So that means we go up 3, right 1. And we're going to continue to do that until we get enough data points where we fill up our graph. So up 3, right 1. And then we'll go through and we'll connect all of our dots with a line. All right, so we have that line here. Now let's go do the same thing here for the purple one. We got a y-intercept of 2. We have a slope of negative 1. All right, and so if we continued on this path, we'd have our line. It would continue on in both directions. Now remember what we call our solution here to the system. The solution to the system is where the lines cross at, and it's where they cross. We just don't circle, we call it a coordinate. It crosses at 2, 0. So the x value of 2, y value of 0. Okay, on here to the next one. So we want to solve this system. 3x plus y is equal to negative 3. X plus 2y is equal to negative 4. And we want to solve it by graphing. And in order to do so, we need to get it in slope-intercept form. So I need to isolate the y. I'm going to start here on the equation on the left-hand side. I need to get it written as y equals. Well, this one, all I got to do is move the 3x to the other side. So I'm going to minus the 3x from both sides. And that's going to leave me with y is equal to negative 3x plus 3. So that's slope-intercept form. So there's line number 1. And now we got to get our second line. So I got to work here and green on the equation on the right-hand side. So I'm going to move the x to the other side. So I'm going to minus the x to the right-hand side there. We have 2y is equal to negative x minus 4. Now I got to get the 2 off the y to get it in that slope-intercept form. So I divide every little piece by 2. That's going to give us y is equal to negative 1/2 x minus 2. So there are our two equations that we want to graph to find the solution to the system. So we'll start with the green one. We have a y-intercept of negative 2. Slope of negative 1/2, so you go from that point down 1, right 2, down 1, right 2, and then we keep on that path and that pattern until we get a full set of solutions. Now, if I run out of room, I go the other way, so instead of down and right, I'd go up and left until I fill all of my points on the graph, and then we'd go connect our dots with the line. All right, so there's my green line. Now I got to do the same thing for the red one. So y is equal to negative 3x plus 3. Y-intercept of 3. Slope of negative 3, so that would be down 3, right 1. Down 3, right 1. Down 3, right 1. And so I connect my dots here and I make a line. Now remember what the solution to the inequalities, or excuse me, the solution to the system of equations is. It's going to be the point where they cross at. So my intersection coordinate. The intersection coordinate has a x value of 2 and a y value of negative 3. So 2, negative 3 is my answer. Okay, well, now we're going to look at a system of linear inequalities again, like we did in the previous video, but this time they're not going to both be written in slope-intercept form. But in this first problem on the left, the first one is in slope-intercept form, the second one is not. So I'm going to have to take my second equation, get it in slope-intercept form, so that way we can work to graph it. So I'm going to move that 5x to the other side. We got 3y is less than or equal to negative 5x minus 6. And then we need to divide everything by 3, every little piece by that 3. And so our second equation is y is less than or equal to negative 5 over 3x minus 2. So there are our two linear inequalities we want to graph. Let's start with the blue one. All right, so y is greater than negative 1/3 x plus 2. So we have a y-intercept of 2, a slope of negative 1/3. So you go down 1, right 3. Down 1, right 3. Down 1, right 3. Down 1, right 3. And I'm going to go the other way because we have to do shading for the inequalities. Okay, so I get my dots here, and I actually got an error. Couldn't count to 3. Down 1, right 3. All right, and I got to figure out, well, what kind of line do I do? We have an inequality. Y is greater than, so I got to shade on top of the line, but there's no line up under it. So dash line, shade above. So I go dash line. So dash line in between these dots. Shade on top of the line. So everywhere up here would be a coordinate that would satisfy that first inequality. Well, we have to satisfy both inequalities, so now we want to graph the green one, the green expression on top of that. So y is equal to negative 5/3 x minus 2. So we have a y-intercept of negative 2. And the slope is negative 5 over 3, so down 5 over right 3. So I can only fit that one point there. Now I need to go the other way, so set it down and right, up and left. And it's a solid line this time, looking at the inequality. And so I have a solid line, and it's going to continue on off the graph. We want to shade underneath the line because y is on the smaller side of the inequality symbol. So all the points underneath this line here would satisfy the green one. Well, I have to satisfy the green and the blue at the same time. So my answer here is going to be, well, what falls inside the common shaded area? Well, that's going to be all of this part here that I'm shading in red. So anything that's shaded by both, and I also look at whether or not I include the lines. Well, I wouldn't include anything on the blue line, but I would include everything on the green line in here because it's solid green and it's inside of the blue. So any point that falls inside of that region would be an answer. Okay, here we go. Last one, we want to solve this system of linear inequalities, and nothing is written in standard or slope-intercept form. So I need to take both of these equations, and I need to write them in as y equals. So I'm going to start with the one here on the left. I'm going to move the 2x to the other side. So I'm going to minus it. That gives me negative 3y is greater than or equal to negative 2x plus 9. Now I have to divide off that negative 3. So from the y, and I have to do that to every little piece. Now that gives me y. And remember, if I divide an inequality expression by a negative everywhere, I got to flip that inequality sign to face the other way. So it becomes less than or equal to, that'd be positive 2/3 x minus 3. So there's one of our inequality expressions. Now let me change colors. And now let's do the second expression, which that one's going to be much easier because all I would need to do would be subtract the x to the other side. And we'd have y is less than negative x plus 2. There are my two linear expressions that I want to graph. And we'll start with the blue one. So y is less than negative x plus 2. So that is a y-intercept of 2, a slope of -1. So I go down and down 1, right 1. And I keep going until I fill all of the places on the graph here. And I go the other way. So instead of down and right, I'd go up and left. And what kind of line do we get? It is going to be a dashed line because there's no line under the inequality. And I got a shade under it because y is on the small side of the inequality sign. So everywhere under this line is going to be a solution to the blue inequality expression that we have. So all of this region down here. Now, let's go do the red one. So y is less than or equal to 2/3 x minus 3. So we have a y-intercept of -3. And then we have a slope of 2/3. So up to right 3. Up to right 3. All right, up to right 3. And I'm going to go the other way. So from my original point down to left 3. Down to left 3. All right. And we have a solid line this time because there's a line up under the inequality symbol. So I'm going to make a solid line that goes through all those points. So everywhere on that line is a possible answer. And since y is on the small side of the inequality symbol again, we have to shade underneath the line here. So everywhere under that line, that red line would satisfy the red equation. So our solutions are going to be the common shaded areas. So let me go ahead, I'm going to do purple for what is colored by both areas. So what is colored here by both regions. So all of this. Now we have to look and say, all right, well, what about the actual lines themselves? I would not include anything on my dashed or dotted blue line because of the inequality symbol. However, this red one here, the parts that's inside of both the blue shaded part and on the red line would have to be included. So all of the red line here in this region in purple would also satisfy both expressions as well.